Hey guys, so 4.2 population of Nigeria. So in 1990, Nigeria had a population of 95.3 million. By 2000, there was a population of 122.4 million, which was an increase of 28.4%. During that decade, the population can be modeled by an exponential function. So we want the population f of d, so make sure you're using precision, in millions of people, so I don't need to worry about the millions on those numbers, just the actual numbers in front. D decades since 1990. So f of d, it's exponential, so I'm going to have my starting number, which was 95.3. Okay. Just like we learned before we went on our little break, exponentials are a times b to the power of x, where this is your initial value and this is your multiplier. Since we are working with a percent increase, this 28.4%, you're going to add that to 100% because it's increasing by that amount. So then your multiplier, that is the decimal, is 1.284. So that's what I'm putting in as the multiplier. And then it's the power of d for decades because it asks for f of d. So in 1996, though, that's not a full decade. D is in decades. So 6 years, well, how many decades is that? That's 6/10 of a decade, or 0.6. So you could use 6 over 10 as your decimal, or as your exponent, or 0.6. So I'm going to do f of 0.6 equals 95.3 times 1.284 to the power of 0.6. A student said the population grew at a rate of 2.8%, 4% every year. The problem is that that student was thinking that it was growing linearly and it's growing exponentially. So we would say no, because it is not linear growth. We can't just cut it in half or cut it by 10 years, even though it's growing. That's the growth for 10 years. Oops, it's not linear. So the actual annual growth rate, right? So we know that for 10 years, we're using 1.284. So for 1 year, it's going to be the 10th root of that, because then that 10 times, or it would be 1.284 to the power of 1 over 10, right? And then that, let's see, we're going to have to go to the calculator. It's going to be about, there's my calculator. So 1.284 to the power of, so I'm going to do x to the y here, and 1/10 is 0.1. So I get 1.025 about. So it's a growth of actually 2.5% each year. Because remember, if you converted that, that would be 102.5%. Well, that's 2.5% more than 100. Okay. So what you really wanted to get out of that is that I could not just divide it by 10. That does not work. You really, really, really want to be taking it to that power, 1/10, because 1 year is 1/10 of a decade. So that's how we do that. All right. Talk to you guys later.